Okay, so in this video, we're going to be looking at compound depreciation. Compound depreciation or decay occurs based on the compound interest formula. Also, this is known as the reducing balance depreciation. So this is your compound depreciation formula. It's the same like if you're going to be looking at it, it actually looks like your compound interest, right? A is equal to P1 plus RT. So in this case of compound depreciation, we are not going to use the plus sign. Instead, we're going to be using the minus sign. So here you have also your P, which is the original value. R is the rate in decimal form. T is time period. And of course, A is your total value after depreciation. Compound depreciation is exponential in nature. So you've been studying exponential functions in our previous lessons, and I believe that you have understood very well about exponential decay. So it is decreasing exponential graph. Here is an example. A car worth $225,000 depreciates by 6.6% annually. Based on a reducing balance, determine the value of the car after 4 years. So let's look at what's been given here. So we have our principal, which is 225,000, and we also have our rate at 6.6%, which is equivalent to 0.066 in decimal. And also we have our time here, which is 4 years. 4 years. Okay, so with all of these things given, let's put it in our formula. A is equal to P1 minus R raised to T. Okay, so our P here is 225,000 multiplied by 1 minus 0.066, and we're gonna raise that to 4. So using your calculator, at the end of 4 years, A4, the total amount will be amounting to only 171,226.12. Okay, so this is the cost after 4 years. Another example, determine the original value of a company's assets if it depreciated to 144,000 after 3 years at 4.5 PA compounded. So in here, we are being asked of the original value, which is actually the principal. So in this case, principal is not given. We're going to determine that. But we are given the final amount, which is 144,000. We are also given the time, which is 3 years. And also we are given the rate, which is 4.5%. In decimal form, that's going to be 0.045. Okay, so let's find the principal now. A is equal to P1 minus R raised to T. Okay, our A here is 144,000. We divide it by is equal to P, and then 1 minus 0.045 raised to 3. So we're going to simplify this one first. So here it's going to be 144, the same thing. However, in this case, we're going to have the principal multiplied. Once you have simplified this part, it should give you at least 0. Okay, let me just write the whole number. Okay, 0.983,875. Okay, it's a very long number. And then we're going to divide by itself in order to isolate the P in here. We isolate this one. So we're going to divide it by this number. Okay, we're going to do the same thing with the other part, this one. We're going to put it here. Okay, So this is going to be cancelled out. This is going to be 1 or only. So what's left here is P, and then put this in your calculator, and that should give you around 165,330.270. Let me just put it that, but this is an estimate of 165,330.330. So that is the principal. Here's another one. A second-hand farm tractor worth 60,000 has a limited useful life of 5 years and depreciates at 20% per annum on a reducing balance basis. Determine the value of the tractor at the end of 5 years. Okay, so let's look at our given in here. First, we are given this amount of 60,000, which represent our principal, okay? 60,000. And we are also given the 20% rate, 20%, which is in decimal. That's going to give you 0.20 only. And our time is 5 years, okay? So we are asked to look at the value at the end of 5 years. Okay, so let's look at this one. A of 5 at the end of 5 years is going to be 60,000 multiplied by 1 minus 0.20 raised to 5. Okay, put that in your calculator. So this should give you an amount of 19,660.80 only. So at the end of 5 years, this is only going to be the amount of this second-hand farm tractor worth 60,000 at the very beginning. The number of pelicans at the Berg River mouth is decreasing at a compound rate of 12% per annum. If there are currently 3,200 pelicans in the wetlands of the Berg River mouth, what will the population be in 5 years' time? Okay, so we have seen 3,200. I guess that's the beginning population. And the rate of decrease is 12%. That's going to give you 0.12. And also, we have time here in 5 years' time only. So let's look at it. So the population, A this time, A in 5 years will be 3,200 multiplied by 1 minus 0.12 raised to 5. Okay, use your calculators this time again. So this should give you around 1,668.74. Now I can clearly say that because 74 is not a whole number. Okay, so maybe we can round it off to 1,669, okay, pelicans at the end of 5 years. So this is what it means. A school buys a minibus for 950,000, which depreciates at 13.5 per annum. Determine the value of the minibus after 3 years if the depreciation is calculated A. Straight line method, B. Reducing balance basis, and C. Which is the better option. Okay, so let's look at what are given in here. First, the principal is 950,000 and the rate is 13.5%, which is the same as 0.135 in decimals, and 3 years time. T is 3 years. Okay, so letter A, let's look at our straight line method. Straight line method is A is equal to P 1 minus RT. Here, that's going to give you 950,000 multiplied by 1 minus 0.135 multiplied by 3. So put that in your calculator. So this should give you an amount of 565,250. Okay. Now let's look at the reducing balance basis. Okay, letter B. A is equal to P1 minus R raised to T. So this is going to be 950,000 multiplied by 1 minus 0.135 raised to 3. Okay, use your calculators again. So this should give you around 614,853.90. Okay. So let's answer the last question. The last question says, which is the better option? So if you're going to be looking at the prices that has been computed in here already, in straight line method, you have seen a very low price after 3 years compared to the reducing balance basis, which is still has a higher cost. Okay, so it means to say that the best choice in here is the second one. So for this lesson summary, we have just studied about compound depreciation, which is actually based only on compound interest. Okay, compound interest. And it is also called the reducing balance method. So the formula is going to be A is equal to P 1 minus R raised to T. So compared to your simple or compound interest rather, that's going to be A P 1 plus R raised to T. I hope you understand this lesson very well. Thank you so much.